My name is Ivana Golub, work for PSNC, and together with our team from Work Package 6, we will present the current status of our work package, what we have done so far, and what are the next steps. I will start with sharing the presentation. Can you all see it?
Yes.
Yes, you can. Yes. Thank you. Before we start, just a few main announcements. Please mute your microphones when you are not speaking. If not, and if we will hear some noise from a few minutes ago, I have this power to mute and unmute anyone on the call. So all of this is just for the main reason to have this, to have all the attendees focused on the presentation and the questions. Since we were approached by people that could not join us today, will this session be recorded? Then we decided to try to record this session. I hope that it is okay with all of you. If there is somebody who is against it, please speak up now. So I will take that as okay. And we have chosen to use the Zoom room because it has the feature to allow chat. So please feel free to use this and ask questions anytime if you have any. Of course, you are very much invited to ask questions during our presentations, because this is the purpose of this InfoShare, to be able to address as many of your questions as possible. So today we will present our Network Technologies and Services Development Work Package by presenting our 3 tasks. Network Technology Evolution, which is task 1, Network Services Evolution and Development, which is task 2, and within this task we will actually have 2 segments. One is the presentation about self-service portal, and the second one is about the orchestration, automation and virtualization work that we are doing within this task. And the third task that will be presented is monitoring and management. And after that, we will provide a little bit more information about the work package and ending with the conclusions. So as you all know, this work package is led by a team and myself. And the budget, the initial budget, is a little bit more than 6.2 million euros. So it is organized in 3 tasks. The first task, Network Technology Evolution, is led by Xavier Jeannin, but Xavier is on vacation this week, so task 1 will be presented by Tim immediately after this brief intro. Task 2, Network Services Evolution and Development, is led by Roman Lapach, and he, together with Maria Isabel Gandia Carriedo, will present task 2. And task 3 is led by Pavle Vuletic from University of Belgrade, who will also present this task. So now I would like to ask Tim to start sharing his presentation and present task 1.
Okay, thank you, Ivana. Okay, it should be coming up now, hopefully.
Yes.
So, can you confirm you can see that, Ivana?
Yes, it's okay.
Great, thank you. So, welcome everyone. Ordinarily, Xavier Jeannin of Renater would be presenting this, but unfortunately for us, he's on holiday this week. So we worked with him to put some slides together to go through the topics that we're working on in task 1. And as Ivana says, we'll present it to you generally, just with each subtask as the original objective, the achievements so far, and the future work plan. So we have 7 subtasks essentially within task 1. These came from the project proposal phase, where the various proposals were weighed up and included into the project. 6 of these tasks have already started. One of them, the QKD, quantum key distribution, we plan to start it in January next year. So as you can see, we've got low latency networking, or LoLa, data transfer node stimulation, the time and frequency networking, QKD, and then the last 3 are kind of loosely coupled together around white box networking, data plane programming, which is something achievable now with a language called P4 on many white boxes, and then router for academia, research and education, rare, and that's about an open networking platform for R&E, again, that would run on white boxing. So the last 3 are kind of connected in the same way that OTFN and QKD are new optical layer sort of services as well. Anyway, on to the first one, low latency networking. So, so the idea here is to investigate creating low latency infrastructures to support real-time applications. So many of you have probably seen the demonstrations of the distributed performing arts at TNC and events like that. So it's that type of application that's in mind here. And the challenge is that the path provided by the network is typically one based on metrics other than latency, such as capacity, the weightings that the routing protocols work on. So what we're interested in here is identifying path latencies using monitoring tools or other tools, then being able to compute the lowest latency path for 2 endpoints to communicate, and then using some form of traffic engineering to steer the desired low latency traffic down that path. So at the moment, we might see situations where the people running these applications, they'll do a simple trace route and they'll see that their traffic's not taking what should be the lowest latency path. They'll see it taking a different path. And at the moment, they'll then contact Jound Ops, who might be able to put up a layer 2 path for them over the network. But at the moment, there's no automated way of doing that or automating the detection of whether you're using the best path. So that's what this task is about. So the key achievement so far is that the monitoring testbed for the work has been set up. We've used Perf Sonar, which you'll hear more about for task 3, as a tool to do the monitoring. And we've also used a new feature that's been implemented in Perf Sonar recently, which is support for the 2-way active measurement protocol, TWAMP, so that we can use that as well to get the latency measurements. The Jound backbone routers support TWAMP. So for example, you can run Perf Sonar and use that to test using TWAMP against the routers rather than against other Perf Sonar points. So that's quite encouraging, and that's working for latency and jitter. And what we plan to do as we go on is work towards a LoLa monitoring solution, working with task 3, doing the Perf Sonar development and using TWAMP. And then what we need to do beyond that, and we can't do it straight away for reasons I'll come on to a moment, is to look at how we might then steer the traffic along the lowest latency path rather than following the default routed path. So one possible solution for that is to use segment routing. The Jound backbone at the moment, the routers support segment routing, but there isn't a controller available yet. It's under procurement soon that would be able to essentially do the configurations to apply segment routing technology to do the steering. There are, of course, other steering mechanisms we could use. Interestingly, at a workshop last week, SurfNet presented on some work they're doing with segment routing on their own backbone. So we'll be speaking to them to explore what might be possible in that area. So that's generally where we're going with LoLa. That's the first of the 7. The next one is data transfer node stimulation. In the proposal phase, it seemed quite clear that a number of NRENs were interested in exploring how to make or to better support large-scale data transfers through their backbones and through their networks. And so this subtask arose. It seems clear from speaking to various people and communities that there are some well-established communities that have come up with solutions for this. Obviously, the WLCG and CERN experiments are one of those. But there's a long tail of emerging science disciplines that want to do large-scale data transfers that don't necessarily have the infrastructures in place or the tools or expertise to do it. So you may have heard of LHC1, or the overlay network for the Large Hadron Collider experiment. So we're seeing some examples of disciplines that feel that they should be able to use that for their data transfers, but that may not be a particularly scalable approach. So what we've done in this, we've done some surveying of the different projects out there that are doing things to improve data transfers. We've spoken to some disciplines, and we ran a survey through the APM contacts and presented the results at the STF meeting to get a feel for what the NRENs are currently doing to support data transfers and what they would like to see. And the interesting conclusion there was that there was no obvious piece of software development we could do to improve things. And most of the issues come down to two things. One is last mile networking, typically within the institution or campus, whether they follow the Science DMZ type of principles that you can see on the diagram on the right here, and also whether researchers are engaged. There are a number of examples we've heard of anecdotally of researchers that are moving data around on hard disks because they've tried to transfer data, not had a good result, and then not known who to speak to. And there is a bit of a challenge here from the joint project point of view in that we aren't supposed to be speaking directly to these researchers. We're supposed to go through the NREN. So it's kind of an NREN campus researcher engagement issue. There was or is a task force, TF-RED, that has been exploring this. It's not clear what conclusions they've come to, but there are many issues here that are not just down to the technology. That's the key thing. So the future plan here is to, from what we've learned, dissemination of good principles, trying to help with user education, looking with the campus network management as a service subtask, which you'll hear about later, to see what we might be able to do as we bring CNAS principles into campuses to help with the automation and the setup of Science DMZ type infrastructures, and to do dynamic infrastructures across a campus rather than just at the edge. And there's certainly work we can do here in collaboration with Task 3's multi-domain monitoring, consultancy and expertise around the use of persona and so on to measure the throughput that the institutions are getting. So that's where we are with DTN stimulation. Feel free to ask any questions as we go along. OTFN, the optical time and frequency networking, this is the first of a couple of optical level network technologies we're looking at. The idea here is around creating a time and frequency distribution service over GÉANT infrastructure. So there are some projects that are already running that we've not mentioned in the slides here. One called CLONETS that's been working on this and using NREN infrastructures. So there is some early work with the metrologist community towards these types of services. The subtask here, they've identified 3 different types of service that could be delivered. The first one is of most interest because it's the most accurate, the ultra-stable frequency delivered over optical frequency. So that's what we want to be working on here. And in the first few months of the project, the subtask has done some good work in identifying the different services and how they could be delivered. They proposed a ring of GÉANT POPs, fibers between GÉANT POPs that could be used for a first stage of deployment, and done a fairly detailed design and cost assessment on that, so that we could work with Work Package 7 to instantiate a ring of time and frequency networking around the GÉANT backbone. Unfortunately, at the moment, the GÉANT ops are focused on delivering the new GN43N. They're really keen to be running a reliable and stable network as they expand things out. So they've basically said at this stage they don't want to be deploying OTFN, certainly using C-band channel 44 on the backbone. So in this year, what we're doing while that issue resolves itself is going ahead with 3 strands of work. So one of them is around the NRENs in the subtask, exploring fiber that they have available now to connect those 4 NRENs together so that they can extend their time and frequency services, but not yet over GÉANT infrastructure. And I believe that may also include connectivity to CERN. We're also writing a report, it's not a formal deliverable for the project, on the various bits of OTFN work that have been done so that we capture the knowledge that we've been building up within the subtask. And that will help inform future projects and other NRENs that are interested in the technology. So there's talk at the moment about a potential CONETS-2 project, for example. And then the third thing we're exploring is the feasibility and value of a potential NREN OTFN testbed facility. So this would have to be something that would be identified to be of value not only to the NRENs already in the subtask, but other NRENs that may get interested in this technology and benefit from a testbed facility that they could use. So that's the current future plan. There are 3 strands of work. The second optical strand of work is around quantum key distribution. So this isn't about quantum computing, it's around using quantum communication infrastructure to distribute key pairs essentially that then can be used for secure communications. So this subtask, it doesn't start in the project plan until January 2020, but we have had encouraged the task members just to have some scoping meetings early so that they can get a more detailed idea of what they're going to be doing when January comes around. The other thing that's of interest here is that there are some much larger European initiatives around quantum communications infrastructure. I believe there's a call coming out soon, or may already be out, for something of the order of 100 million euros to establish this quantum communications infrastructure around Europe. So there's big things being planned here, and we're just a small strand of work, a subtask in a task here. So what we're trying to do is to identify where we can add value to that. What can we do at this stage that may be a precursor or something useful, complementary to the other work that's going on. So we're going to hold a workshop early next year to assess the current NREN community interest. There was clearly interest in this at the point the project was pulled together, and we want to sort of validate where the interest is early next year, and to set the work in the context of the other initiatives that are happening, and to make sure that if we are doing something, it's as a use case, it's of interest to NRENs. We will look for potential tests that we could run, but obviously at this stage, the equipment is quite bespoke and quite expensive, so we need to be careful about that. So that's QKD. The last 3 subtasks I'll just quickly go through are around white box networking. They have that as a sort of a common theme. So the first strand of work is around taking what you might call vanilla white boxes, the simpler white boxes, and trying to deploy them in places where you currently use traditional switch and router devices. A white box in general is just a device that's manufactured from commodity components upon which you can then run either a commercial or an open source network operating system. And in theory, I say in theory, you have the property that you can, for a given hardware, change the network operating system, and for a given network operating system, change the hardware that's under it. So you have some principal independence of the software and hardware. In practice, what we found is that that's not necessarily true in all cases. As a general principle, it's kind of okay then. And the idea, the objective here for the white box networking subtask is to explore the use cases for NREN networks. Where could we put these boxes that make sense for NRENs? So the big push on white boxing in the commercial world is around data center. Potentially there's also the internet exchange router, institution, campus, CPEs, provider routers. There's many use cases that we are exploring. So what have we done so far? We've had a number of workshops and events where we've been speaking to NRENs, capturing their expectations, understanding where they think they are around adopting white box. So we're reporting on that. One of the issues that's come up is whether white box devices can perform in the same way that traditional devices can. So for example, there was a concern raised around buffer sizes in white boxes. Do they have big enough buffers to be able to deliver high throughput? So we're looking at that. But the main area is around identifying and exploring use cases. So we have a number of NRENs that are deploying white boxes. Well, the plan is to deploy them into production through a test phase, into a pilot and into production. So there's about 5 areas where we're doing that to get real production experience. And so far, from what we've done to this point, it seems that there are certainly some use cases where white boxes appear to be good, but we have uncovered some features that are missing that make it not necessarily that viable in other use cases at the moment. But it's a very moving target at the moment, so we expect things to change as the project progresses. So the two that are in early production, there's the CPE Normandy, which is Renaterre, obviously. So they just last week or the week before, I think, got the first white box in production in a high school network. So there's more to come there. Early results are encouraging. And the second one is a French internet exchange point, where two white boxes are recently being installed and they're being migrated into production. So those are the early production deployments we have, the CPE and IXP. And the ones that are currently still in the lab, but hopefully moving out of there soon. There's FUNET also with the CPE. You'll hear more about FUNET and what they're doing with campus networking as a service later on today. So this sits as part of that. The provider router, that's an edge core device, 100 gigabits per second throughput supported with plenty of LSP paths. So that's been encouraging so far. Thirdly, the data center fabric. Interestingly, there we have two cases, one of which we're awaiting a tender result. The other, we were hopeful that it might adopt white boxing, but the traditional vendor came back with a very competitive bid. Obviously, we can't really say too much about that for obvious reasons, but it seemed that the traditional vendor was happy to reduce their pricing significantly to try and be competitive with the white box solution, which is an interesting point in itself. So that's white box networking, with just taking the devices and putting them in where existing traditional technology is being used. The future plan, we're continuing with the performance tests, for example, around devices with larger forwarding buffers. We're looking at other use cases and how we might investigate those. So 3 strands of work there. One is interoperability tests between white box and non-white box equipment. One is looking at a firewall implementation for the white box for CPE Normandy. We're also looking at cost-benefit analysis too. And we'll continue to collect feedback from the production use cases as they go forward. And our last point there, I'll come on to RARE in more detail in a moment, but we're building a test bed for the open router platform RARE that we're building in the project, and we'd like to be testing that with generic white box devices. Onto data plane programming. This is a new thing that's come up as a result of the evolution of a language called P4, which is supported by a number of white boxes. The idea here is that you can essentially program a P4 compliant switch or router device remotely using the language. It's not that dissimilar to winding back a little bit with SDN and OpenFlow. So what we're trying to do in the project is to look at some use cases that would be relevant to NRENs and to explore how feasible it is for this technology to deliver what it promises. So one area is around monitoring, the other is around DDoS detection and mitigation. So at the moment, in the early stages of the work, we've done a P4 implementation of the DDoS detection using a method called a sketch algorithm that's working in a virtual environment at the moment for a simple switch model. As you'll see in a moment, the future plan is to, well, it says below actually, the future plan is to move that towards a more complex virtual environment. So that's for the barefoot switch, and then on to a physical P4 switch. From the point of view of the monitoring, we're looking at inbound network telemetry into there. So there's an implementation that the project's done so far in the VDH language rather than P4, which is being applied to FPGA at up to 200 gigs per second. And that the future plan there, and it's the current work, is migrating that to a P4 implementation with the latest version of P4, version 16, for the FPGA card. And then the final thing I'll mention today is the router for academia, research and education, RARE. The idea of this is to build a platform, a network operating system essentially, that can run on a white box platform, and such that we have an open source control plane with a P4 data plane, and apply that to use cases of interest to NRENs. So some of those are listed there: Internet Exchange Point, data center, CPE, etc. So that's the idea of this project. The key achievement so far is that the people working on it have picked an open source control plane, free router, and they have successfully connected that with a P4 data plane in a virtual environment, again for the barefoot switch model. And they've developed quite an impressive and integrated quite an impressive set of features so far. So both v4 and v6, MPLS, VPLS, EVPN. So that's gone faster and further than expected. So we're very happy with that. If you're interested in a demonstration of this platform, there's a nice video on the work on segment routing that you can look at on YouTube if you want to see a sort of a hands-on example, a recording of that. And then the future plan, this is I think the last slide, is to take the development so far and move it on to a real physical switch, develop new features, look at streaming telemetry for the platform. And for all this, we want to build and extend a European testbed. So we have 4 switches that have been bought so far. They cost about 6,000 euros each, the ones we're deploying. Those are going into Géant POPs, and then 3 NRENs have also bought their own equipment with their own money, and those P4 switches will be connected into the testbed. So if you want to connect in, you need to find some way of getting a layer 2 path between the Géant POPs and where you are. So we've bought a router at JISC, a switch at JISC, around a Terraport 2, and a switch is also included in that testbed. And I think the switch is one that's live now. That's the future plan for that's everything I have to cover. If there's any questions, feel free to ask them. Otherwise, I'll hand back to Ivana.
We are waiting for questions. Maybe Tim, you can unshare, and Roman, you can share the presentation.
Okay, I've stopped sharing. You should have control again.
Okay, I will try to share my screen. Okay, Ivana, can you see mine?
Yes, we can see the slides. Thank you.
Okay. Should I start?
I guess there are no questions for Tim now, so please, Roman.
Okay. My name is Roman Łapacz from PSNC. I'm the task 2 leader, and I will present the task, the development part. So first, 3 objectives, main objectives of the task development part. So first, development of network service provider architecture and framework for service orchestration and automation in a single and multi-domain environments based on standards and OSS BSS principles. Second, piloting and deployment of the service provider framework for managing network services. And third objective is self-service automation with the use of self-service portal, which is one of our framework components, to order a service within minutes, only minutes, and keep control over it. So these are main objectives of the task 2 development part. In this slide, next slide, you can see the simplified picture of our framework with self-service portal as a front-end GUI and service orchestrator, which manages business processes and calls other framework components and external tools like CRM component, inventory, or OTRS application. All the communication between components is done via standard TMF APIs. The slide presents the definition of the third network vision proposed by MEF organization. The vision is based on network as a service principles and shows network services which are on demand and based on virtual resources. A user can create, modify, and delete services via a portal without the knowledge about the internal technical details. So we believe that the self-service portal that we have implemented fits perfectly this vision. Key achievements of the task 2 development part. We have developed a framework which implements the service provider architecture based on TMF standards. We've got reusable entities, business processes, and abstraction and APIs developed. The framework is TMF compliant. The framework is highly distributed with a set of microservices. We had security code audit done by Work Package 9. We test our implementation in advanced test environment within GTS testbeds. And we use DevOps tools available in the Jean project. Second key achievement is our framework is an important element of new Jean connectivity service, GCS. This service is the end-to-end connectivity, and it's being developed by Work Package 7. So now it's in the test, we've got test deployment in the Jean infrastructure. Future plans, support for GCS, together with Work Package 7 and the Jean Ops team. We want to move the GCS from the testing phase to the production phase. And all the time we will be offering the support to Work Package 7. And in the task 2, we are working on new functionalities like EduGain integration, policy management to control access to the resources available in our framework. And we are working on user support improvements, so like documentation, better visualization. We are working hard to make the self-service portal more user-friendly. So Maria, can you continue?
Sure, if there are no questions for you. Okay, so if there are no questions for my colleague, then I will just start sharing. Do you see my screen? Okay.
Yes.
Oops. Okay. Good afternoon. I am María Isabel Gandía. I work for CSUC, a consortium of services for the universities in Catalonia, and I'm here on behalf of Rediris, the Spanish Research and Education Network. I have recently joined this subtask about consensus building, so I must say that Suzanne helped me a lot with preparing this presentation. And I will just give a brief introduction of what we are doing here. We are investigating on OAB, and just to clear it, OAB stands for Orchestration, Automation, and Virtualization. And this subtask inside Task 2 aims through its consensus building discussion and its development and workshop activities to promote a wider adoption of general service orchestration and automation principles within the NRAN community. So to start working on OAB, the first thing this subtask did was to release a survey to the NRANs. And in this survey, many things were asked about the current work, the platforms, the use cases the NRANs were having about OAB, the challenges they face, and their future plans. So the idea was to learn about the strategy and actions of each NRAN related to network and service OAB, and also to explore if there are common OAB use cases, ideas, and issues in the community. and recognize possible areas of collaboration among the NRENs and GIAN, and among the NRENs by themselves too. And also to determine the possible future work within Work Package 6 or other work packages that could be of benefit to as many partners as possible for identified use cases. This survey contained 35 questions organized into 5 different areas. It was sent to the NRENs, and it was answered by 31 senior managers at the NRENs, which gave very valuable information about what they were doing or what you were doing. The results of this survey were discussed both within the GIAN community and also with the international community outside also of GIAN. Within the GIAN community, it was discussed during the Future Service Strategy Workshop in Amsterdam in May. And there were like around 70 NREN participating there. And with the international community, it was discussed in the BOF session at TNC in Tallinn, where there were people from other regions of the world. There were OAB activities presented that are being done at the United States from Internet2 and SNet, and also from Australia, from IRNet. And well, you have all the information in the link you see here. And there was also a presentation on STF, on the 17th STF around OAB. These results of the survey clearly showed several things. One of them was that there was a diversity of perspectives. Many NRENs were working on OAB, and the maturity was very different for each one of them. Some NRENs were very mature, while others were just starting, and others were doing nothing about OAB. So it was clear that there was a need for dissemination and collaboration activities, and to bring together the community around OAB topics. Thus, the workshop I mentioned before, the BOF, and also the 17th STF, Service Technology Forum participation. So, as the NRENs are at varying stages, it's very important for them to share this experience. And there's also a need for strategy for OAB in GIAN. This strategy means that we need to know where we want to be in 4 years in the community, and also how we want to have this orchestration and automation working at the beginning of GN5. The results of this survey, and also a brief market analysis related to OAB topics and the plan future work, are available in detail in the deliverable 6.2 about automation and orchestration of services in the GIAN community. After this survey, there was a clear intention of working in different things. So the group in subtask, in this subtask in task 2, divided into several focus groups. These focus groups were working on different specific topics, exploring these topics, discussing and documenting best practices, helping to promote OAB technologies. The 4 first focus groups established were this that you see here: terminology, architecture, use cases, and the wiki. Terminology was because the workshop showed a need for an agreement on common terminology. Architecture, because there was the need to study a variety of architectures and frameworks. There are several of them. Each provider also has its own architecture. There are many architectures out there, and we need to see what is useful for us and what we can just use in the future. And to see if there are common approaches that should be considered as part of our strategy. Regarding the use cases, the first case was campus network management as a service, because some NRENs are already doing things around this topic. And the focus group on Wiki is for knowledge sharing and global exchange. For the terminology focus group, the idea is to have a common ground of understanding or a common document with all the information, because there are no documents currently that include all the information about terms used in orchestration, automation, and virtualization. So this focus group is right now building a list of relevant OAB terms and acronyms with several commonly accepted definitions and reference, and using, well, they are just sharing all the information they find about these terms and trying to reach consensus about the definition of each one of the terms. This list of terms will be agreed within the subtask team, and then it will be shared, and one of the places where it will be the wiki that I will mention at the end of the presentation. For architecture, it's more or less the same. There are several architectures out there, and the group is now investigating in a broad overview which OAB aspects are covered by each architecture, what are the standard-based architectures, the commercial products that exist, and now they are working on the requirements to see what will be the architecture that will fulfill the requirements of the GIAN community. In next month, a decision will be made on which architecture should be explored in detail, and taking into account all the GIAN and the NRAN community requirements, and also the global approaches, the standardizations, and the strategies. Regarding CNAS, this is a work that began or started in task 3, and there has been a lot of communication between task 2 and task 3 with this. It's also that because NRANs are offering CNAS, are using OAB techniques. If you want to give a service to many different customers, it's better that you automate things. But also the different approaches are taken, and there's the clear need to share information as with all OAB staff. So the initial purpose of the focus group was to liaise with the NRANs that are working on CNAS and collect information and provide the service definition. And Pablo will talk about it later when he talks about task 3. The focus group now is working on the deliverable 6.4 about campus network management that will include this service definition, the examples from the community, and the summary of the workshop that Pablo will explain. But the idea with CNAS was to use the model to approach the community, and then to replicate this model to approach the community for other topics, to define the scope of the work and work around other topics that are not just CNAS. The last one is the wiki. There's a public OAB wiki here, but we are working internally on an internal mirror site that is having more information. We put all the information there, and then we put it publicly on the wiki. The group works continuously on this internal mirror site, and then updates to the public OAB wiki regularly. All the documents, the links to standardization bodies, the events and InfoShares are there. And there's also an OAB community portal where I would encourage you to send all the information you have. If your NRAN is doing something about OAB and you don't find it in the OAB community portal, maybe it's because we don't know it. So you have an email address here. You can use it to present your work, and we can put the links in the wiki so that we have a wiki that is useful for the community and that has not just the community portal, but all the terminology, the architectures, and all the work that has been done in this subtask. And this is all from my side. You have any questions? Okay.
Thank you, Maria Isabel. Pavle, could you maybe share your slides?
Okay. Ivana, can you please confirm that you can see me and that you see my slides? Okay.
Yes, yes. You can see slides.
Okay, hello everybody. My name is Pavle Vuletic. I'm coming from University of Belgrade, Amres. I'm the task leader of work package 6 task 3, monitoring and management. And this is the task, which is quite large. It has around 30 participants inside, with a total around 10 FTEs. It is unique in this work package because it contains some of the GIAN official services. The first one is Persona. I think the majority of you know well what Persona is. This is the set of tools for monitoring network, and the role of task 3 in Persona is to participate in Persona global team and to work on the development of new Persona releases. then to develop some new functionalities and support some new use cases which are unique for our Giant environment, and to support Persona users. So what was happening since the beginning of this project is that Persona version 4.2 was released, and it has some nice features and some useful features like DNS measurements, HTTP measurements, namespace integration, similar stuff, which is quite useful for especially for the CNAS use case that Maria Isabel just mentioned a couple of minutes ago, because now with using Persona, it is possible to create a small box, a small probe that would be placed in a campus network which is being managed by the NREN, and use it to verify the quality of various services in that remote network. As you can see on this slide, we worked on Elks Tech being used as the UI for Persona, because some of the measurements like DNS and HTTP still don't have native Persona visualization, so we had to adapt it a little bit to be able to see these results. The subtask also worked on Grafana UI measurements for on-demand measurements, and the task also organized the first European Persona user workshop, which was held in London in June this year. Persona will continue its development with the global team and the multi-domain consultancy and expertise service, which I will tell a little bit more in a few moments. We plan to organize the second European Persona user workshop, because the first one we gathered quite good feedback from the participants. We also consider organizing some training events for the users of Persona and PMP platform, which is going to be described a little bit later, and to support more use cases that emerge from our community. The next activity within the subtask, which is largely overlapping with Persona, is the service which is called Multi-Domain Monitoring, Consultancy and Expertise, where the task is providing training and running workshops on Persona deployment, usage, and best practice. We are also providing some extra support to assist Giant and NRENs to deploy and operate Persona if they request such support. And in this year, we've been giving support to the Praise project to deploy Persona on their MDVPN service that they are using within their infrastructure. As Tim described at the beginning of these presentations, we work together with the LoLA subtask in task 1 to help them to measure latency and especially jitter between the LoLA project sites. And I think that we made quite good progress there, because I think that it is now clear how this can be done, and the architecture for monitoring all the required links for the LoLA project, I think that is more or less well defined. We also helped the CNAS group to provide this application level monitoring with the Persona small boxes, PMP style small boxes. And Renater and Arnes got some help from our team to deploy Persona in their networks. So the plan with this service is to continue in the next year if there are some further requests from the users or other projects. The next service within the task 3 is PMP. Maybe some of you know this as it was formerly called Persona Small Node project. This is a set of small boxes, small computers, which are given typically to the NRENs, but also to some other institutions within the NREN. There are some NRENs which have more than one box, and which are being used as probes that run different types of measurements. You can see one of the dashboards on the right side of this slide, which shows the throughput measurements from various nodes in different countries in Europe towards the 5 Persona nodes in Giant network. The service was established in the previous project, and the plan for this year was to spread the footprint of the PMP mesh. And the goal for our project was to give the PMP boxes and to establish nodes in 80% of the project partners. And we are right now at the 75. So I think that we are going to achieve this and this was the target for us for the whole project. So we are going to achieve this, I would say, much quicker than we expected, and we will then move and try to spread even further the footprint of the PNP.
I'm seeing a log me in window on top of the presentation. I don't know if everyone else is, but if it can be moved out of the way of the main presentation, that would be great.
I don't know what is log me in. I don't see it.
Seems to be
it's a good.
I don't see it.
It's okay.
okay.
don't see any
Continue.
of it.
My mistake. It's obviously just appearing for me. It might be something to do with my recording, but carry on. Sorry.
Okay, no problem. So what we also had to do is to migrate the nodes to the new version of Persona. And as I said, we achieved 75% of project partners to have PMP nodes deployed. This means 11 new PMP nodes, which we delivered in 2019. So the plan is to expand further the footprint of the PMP, and also to explore how to use other types of measurements on PMP boxes, like HTTP or DNS measurements, which can then give to all the NRNs who participate in the PMP mesh, I would say, quite powerful tool to describe various types of services as they are seen from their network. The fourth service, and the last one, which is in full production from my task, is NMAS, Network Management as a Service. NMAS is a platform for delivering management applications to those users who either don't want to do the whole process of installing and maintaining these applications, or who don't have capacity to do that. So these can be either NRENs who would like to test something and not to use their own resources, or this can be some end users who don't have sufficient resources or expertise to build everything from scratch. The whole platform is based on Kubernetes and on Dockerizing various network management applications. And this was, NMAS was established as a service right before the beginning of this project. So the plan for this year was to onboard first users, to maintain and improve the code base, and to improve the service infrastructure. So what we had to do at the beginning was to establish the VPN infrastructure, which was finally established near the first half of the half of the year. Because if the management application is in GEANT or some NRN infrastructure and the end institution is in another NRN, then a bit of information security has to be taken care of. So we wanted to establish an encrypted tunnel between the managed infrastructure in the institution that is using NMAS and the NMAS infrastructure. We also established in GEANT and in PSNC NMAS infrastructure that can support the service and that can allow us as a task to play and test with new features and to have a quicker release and deployment cycle. We added some new service features like language support, Kubernetes backup system, cluster management automation, monitoring the whole infrastructure, and so on. And recently we started to add the first users, and the first users are from CYNET, from FAU University from Germany. Also, one of the schools from Slovenia, Franja Maglaja, called us recently, and we will provide them support to use the first NMAS applications. The plan for NMAS is to continue to be proactive in attracting new users because the platform is more or less mature, and right now the most important thing is to have more users, and we have to find ways to approach a wider set of users for this platform. Of course, the software will be developed further and tweaked and adapted for some potential new users, and we will add some new tools to the platform if needed and where appropriate, if there is a demand from the community. The next subtask in task 3 is Wi-Fi Mon. This is a platform for monitoring Wi-Fi networks. This is the activity that started in the previous project where it was built around the idea of using users' devices, computers, laptops, or tablets or mobile phones as probes in the Wi-Fi network and to use them to gather the performance results. In this project, we wanted to go a step further and to create a hybrid approach which means adding also hardware probes, and we did that with the Raspberry Pi based hardware probes that can monitor the Wi-Fi network from the fixed point, and we wanted to see what is the accuracy of the results gathered from the user devices and from the hardware probes. The plan was to pilot this new approach and to prepare Wi-Fi MON for the PLM gates to push it towards the service, to become the new GN service. So what we did is that we investigated various Wi-Fi monitoring approaches and the commercial tools that exist that can do something similar as Wi-Fi MON, to be sure that we are not reinventing the wheel or doing something that already exists. We also liaised with the Work Package 5 in order to see what they are doing with the EduROM monitoring, because we didn't want to overlap with their activities, and we very quickly found out that this is not going to happen, because for EduROM and for Work Package 5, it is more important to monitor the radius infrastructure than the access points and the quality of the Wi-Fi network. So we finalized the first hybrid Wi-Fi MON prototype in April 2019. We piloted it and did the first demo at the TNC 19. So all these results were reported at the TNC 19 at the session which we had on the last day of the conference, and also at the CPME in July. So what we are doing right now, and is that we are adding. Actually, the correlation with the EduROM logs is finalized, but what was recently added to the Wi-Fi MON features is the encryption of the private data, because if someone wants to use Wi-Fi MON and correlate all the results with the EduROM, then there are IP addresses and MAC addresses which are considered that can reveal the private information. And so we found a way to use the system in the same way and to have this information encrypted, and thus GDPR compliant, I would say. And we worked also on measurement visualization. So you can see here one of the results, how the throughput of one of the access points looks like. And in this slide, you can see that the IP address is encrypted and that it cannot be seen if someone wants to hide this type of information. The plan with the Wi-Fi MON is to work on the service definition and to prepare all the documents for the PLM gates. We plan to push Wi-Fi MON towards the first gates in the first quarter of 2020. And also, we will give the code of Wi-Fi MON to the Work Package 9 for them to do the code audit and to prepare everything for. We hope that Wi-Fi MON will next year become the fifth service coming from the task 3. Fifth subtask in task 3 is called CNAS, or Campus Network as a Service. This is an initiative which came from SUNET and Uninet, who got a request from their user base that some of their users, some of their campus networks wanted them to manage their own infrastructures. And this was given to task 3 to see and to explore the need for this service in various areas, to explore the potential for the development of some supporting tools for the CNAS, and to explore the potential use of NMAS for the CNAS use case. So what we did is that we talked a lot with the NRENs. We extended the list of the NRENs who are working on the CNAS type of service, and we have now FUNET on board within our task. And we also know that CARNET, ARNES, AMRES, they are all doing something which is not necessarily in the area of managing wired infrastructure in the campus networks, but more they're managing more the school infrastructures or the school Wi-Fi networks, and this is, I would say, the same type of service, just the end users are slightly different. We also organized the workshop on network management and monitoring, which was last week in Copenhagen. We had over there 28 different NRENs who were present, and I think that this already says that this type of service is something that maybe become a common type of service that NREs are going to start to offer to their end institutions. There are many reasons why this is happening. I don't think we have time and we should go into that detail right now, but this seems to me that, that is something that is going to happen very soon. So we also did the non-technical work on CNAS, and this means that we've been working on CNAS service definition that Maria Isabel mentioned, where we wanted to capture all the important things that the NRENs have to think about when they start to offer this type of service. The future plan for the CNAS is to support the deployment of network services in NRENs connected campuses and schools, to support the collaboration between NRENs interested in deploying CNAS solutions, because one of the feedbacks that we got last week from the workshop is that NRENs like to see what the other NRENs are doing in that area, and they like to capture the experience of other NRENs and to this way find the most appropriate approach to their work. So probably CNAS is going to be moved a bit more to the task 2, and because at least at the moment we don't see some direct technical work on the CNAS to build some applications that would be widely used by many NRENs. So probably this is going to be much closer to the OAV work, and this is where it might end up in the next years of the project. The last subtask of task 3 is the incubator, where we are looking for some new approaches to network monitoring and management. And you can see we had several objectives at the beginning of the project. One of them was to take a look at the flow monitoring proposal that we got from the GPPC as one of the proposals which passed the process of pushing towards the GEN for phase 3. We did the analysis of Persona and Netmon features and the potential to integrate the two tools and to use Persona for Netmon type of monitoring. We supported LoLa measurements, as Tim explained in his presentation. We also did, we wanted to explore the use of data plane programmability for monitoring. And one of the things which I think is also very interesting to the NRENs is something that I call zero footprint monitoring, which means using virtualized virtual machines on routers. For example, as you can see in this slide, what we tested is the use of Ubuntu, which is installed on Cisco CSR1, where we can install any monitoring application, which means that there is no need anymore for a dedicated device that would do the monitoring, but everything can be done from the router box. We did the similar with the T1 tests on Juniper routers. So I think that in future we will see a lot of integration of monitoring tools on the network elements. So what we did in the last couple of months is that we actually didn't work a lot on flow monitoring because we determined that there is not sufficient interest in the NRENs for common tool development. So this work was stopped. We created the technical solution for LoLa jitter measurements. And we are working right now on the automation, which can be probably on Netmon, but this discussion hasn't finished yet. We worked a little bit on in-band network telemetry on P4 enabled devices. We explored this, I would rather say more than worked on it, because we are expecting some cards to, we actually able to deploy this type of monitoring. So you can see here also on these slides the way this whole analysis of jitter and how LoLa, for example, is calculating jitter and how T1 code is calculating jitter. So it was very detailed analysis, and I would say that LoLa team can get very, very reliable results about the jitter now with the methodology that we established. So the plan for the future is that we want to scan for some new approaches that are relevant for the NREN community in the area of network management and monitoring. We want to work on network telemetry for NRENs in the year 2, and I believe that we will have some first results as soon as we get the cards. And we are exploring the possibilities to enhance or develop new services for identifying locations and causes of performance degradation. And that would be all from my side. So I will stop sharing. I guess we will have discussion in the end, at the end.
Thank you, Pablo. Any questions for Pablo? If not, I will proceed with the final few slides. Yes?
Sorry, I do have a question. With maps, which tools are included at the moment in them for monitoring?
So, could you repeat?
Can you please repeat the question?
Sure. Which tools are included in Nmaps at the moment? What type of monitoring tools are available?
Okay, at the moment we have NAV. NAV is the tool developed by Uninet. We have Grafana. Ivana, can you please help me with this?
We have OpenNTI, we have Oxidized, Prometheus, Grafana.
Grafana, yes.
And there were two more. But the point with these tools is that what we learned from the beginning when the platform was designed and then when it was created was that literally any tool can be integrated with NMAS. So after several tools were integrated, then we stopped with adding new tools unless we have some user requesting for some tool to be added. So for example, for the monitoring of performance measurement platform small nodes, it was needed to have Grafana and Prometheus because these tools were used to monitor the small nodes before we had this NMAS instance. So then it took a few weeks to add those two tools, few, like one tool, not 10, 12. Then it can really be added as it is needed per use case. The NAV tool was added because Uninet was considering also using NMAS for their CNAS use case, and also it did not require too much to add this tool to the platform.
Thanks very much. And is it typically open source tools that are included for it?
Yeah. Yes, there is one tool which is OpenNTI, who is actually used also by Juniper. I see that we have a comment on that
I put the link to the NMAS tools in the chat, so you can see.
Oh, that's great. Thanks very much. So I have another question on CNAS. Can you explain what you foresee is going to be the service delivery model? Because it's a bit unclear to me if it's something that Jean provides to the NREN, or the NREN to the end user, or Jean to the end user, or what is the structure?
So Paolo, do you want or?
Yeah, I can maybe.
Okay.
So Campus Network as a service is a service where NRENs are providing service to their end institutions. And CNAS in Task 3, the initial idea with CNAS in Task 3 was to explore whether we can develop some tools or whether we can somehow contribute and help all the NRENs to offer this type of service. However, the problem with this is that all the NRENs have different software architectures, are using different tools, and it is very, very difficult to create a single tool that would help all the NRENs. And this is why it is very challenging, I would say, to offer to provide something unique from this task. And this is why I don't see that CNAS can be provided as a service from Task 3. It is not something that Géant will finally offer.
I think that I can just chip in. I agree with everything that Ivana and Pavle said. I think there's a couple of points I'd make. One is we were really surprised by the number of NRENs and people that registered and came to the workshop last week. There were over 50 people in person and remotely to both present about and discuss campus networking as a service. So it's a much bigger area than we thought. So I think this is something we need to bear in mind for year 2. The second thing is we were able to work with Isabel and others in helping to produce a generic service description for CNAS. So I think that's useful for everyone. Obviously that's not a service, but I think it's a key benefit we can share with the community having done that. And I think we now need to look at the other work we're doing in Work Package 6 and how we can apply that to help NRENs with their CNAS deployment. So one is around the area of automation and what best practices could be applied there. So that's why we have a focus group in that area. The other is that came up at the workshop is there seem to be some NRENs that would be interested in a very lightweight monitoring probe, so something that could run on a Raspberry Pi, do loss latency measurements, use the Wi-Fi Mon code base as well, to be a sort of a probe that could be deployed in campus environments. So that might be something, sort of a very small node that could become something we develop within the project, but we're exploring that in the incubator. So I just thought I'd add that.
And also a third thing that actually appeared that we've seen last week during and after the workshop is the collaboration among NRENs that actually were discussing about each other's solution and each other's use cases. So if in some way the project can help in facilitating to have more of such collaboration, that might also be of benefit. But as it was said, at the moment there is nothing that we can produce as some solution that will fit everyone, so we are not even going in that direction, apart from what Tim said already. So okay, there was a question from Ian to Pavle, but I see that Pavle answered that question. At the moment, there are no costs for using NMAS. We are suggesting two modes for NMAS. One is to use it on central instance, maybe for a trial run to see how it works. And to answer the second question, we will write in the email chat. Actually, you can use NMAS at lists.geant.net to address our team, or you can use our email addresses Ian, for the first contact, and then we will contact you directly from somebody of our team members that can help you deal directly with opening a trial instance. And the second way for those NRENs that have more instances is to have their own instance of NMAS installed in their own NREN. We have an example of Renater who is following that approach, and in that way you can actually provide this service to your users. And as Pavle said, we were exploring this option for CNAS, but at the moment we learned that all, for example, Nordic NRENs are just starting with this, so they have a few pilots running, and at the moment there is no need to have a lot of separate instances at the same time. So at the moment it is not yet important for them, but we are still open to see how it will be developing and maybe to continue with this later. Any more questions related to task 3, or shall we? Okay, I will then continue with a few numbers related to work package 6. So we have 79 team members. So you can see that this is a small organization for itself. And they're coming from 32 organizations from 23 countries. We have 23 NRENs, but also 8 third-party organizations and also GEANT Association team members participating. Overall manpower that we have is 23.1 FTEs during the, it is average for all project years, but for some tasks we have some work items starting and ending within this 4 years. For example, in task 1 is Tim said. So 2.5 FTEs in task 0, which is management task. 5.5 FTEs is in task 1. 5.35 is in task 2, and 9.75, which actually have for production services, is in task 3. As you could have heard, we have 19 small projects within our work package, 8 of them being in task 1. 4 in task 2 and 7 in task 3, with 4 of them actually spreading across different tasks. So we have tried very much to interlace the work that we have in one task with the related work in some other task, and not to keep this in silos. So we prepared these slides before we received the report for month 9. So this analysis is based on the first 8 months of the project. And we have recorded there are 12 organizations that at the moment have some underspend, and also data missing for 7 organizations. So we were not able to include this in our reports. We have 20 persons that are underspending and 5 persons with overspend. And also for 5 persons reports are missing. We have already started to contact UNRWA representatives with any of these elements, either with underspend or with overspend, to clarify this. And on this table you can see what is the current status of the usage of our manpower. But we would really like to improve this, and we would like to ask you to help us to see if we can improve these statistics. We really appreciate your help so far. Related to this, and also we hope that you can help us also in the future to use all the available manpower that is contracted with the EC from each of the UNRWAs and the project participants, then to check that the reports are submitted on time, so that we avoid that we miss some reports from some organizations, then that all the contributions are recorded and that are presented in the reports, because we've seen that some persons are very active in our meetings and contributing and providing the outcome and participating in the work, but then in the reports their contributions are not seen. Also, we do have a lot of very active team members, and we are really grateful for this. But also, we see some that are not that much active. And as I said, we have started to contact UNRWA representatives, and we will continue to do so. But for example, if you are aware of somebody leaving or somebody being tasked with some other things so that cannot participate actively in our work package, please contact us, and we can discuss whether it could be replaced with somebody else with the appropriate skills, or maybe if that person could be moved to some other task where he or she could contribute better. And also, if some manpower is not spent, then please help us release this, either if it was not spent previously, and you cannot actually dedicate person more in order to make up this underspend, or if somebody will not be available to work in the future, because we see already that in some teams in our work package we could use more manpower, and we need more manpower, but at the moment all the manpower is locked, even that one that is not at the moment used, because it is dedicated to a particular UNRWA. So if we cannot release it, then we cannot use it, and then we will continue underspending, which I think we can all agree is of no benefit to anyone. So we would really appreciate if you can help us in the future also with this. I see that there was a question. Let me just see. Creating a sustainable model is probably high on our agenda. It's also hard to recommend a service to clients without knowing if the service will be sustainable long term. Okay, this is a question this is a comment for the previous. I assume this is related to ANMAS, right? Ian, do you want to comment something?
No, Ivana, yeah, sorry, it was just a comment on the previous one. Sorry for the confusion.
Okay, no problem, no problem, it's okay. Yes, so, oops, just a second. So, as I said, we will we will continue to contact individual UNRWAs about the manpower, but I just wanted to use this opportunity, and I'm very happy that today we have more than 20 UNRWAs participating in this InfoShare to actually see our side of the budget and the project management. So in work package 6, as Paula said, we have 4 services that are in production. Those persona, multi-domain monitoring, consultancy and expertise, which goes hand in hand with the persona, performance management platform and NMAS, and also 1 service in pilot. We have collected some statistics about the current usage of these services. So based on the UNRWA satisfaction survey, which is relatively latest info that we got about the usage of persona, we have 25 UNRWAs that stated that they use persona. For multi-domain consultancy and expertise, we have 9 use cases from the previous project, 5 of them in this year. We have 6 UNRWAs that have contacted us and with whom we worked on implementing either persona or some other monitoring tool within their environment, and 3 projects. For a performance measurement platform, we have 28 UNRWAs and 38 project partners that are currently using this service. And for NMAS, we have 1 project and 3 institutions from 3 countries onboarding to use NMAS, with 2 individual instances in 2 UNRWAs. So we would actually like to increase the service uptake, and we would really like also your support. We really appreciate your help so far, and we hope to continue in that direction, either to use our services as is, either to pilot or test with or without the intention to use it on a longer run, to request features to help us create new services that will be useful, but also to help us to promote services to your institutions, since we acknowledge and accept the service delivery chain which goes from the project towards UNRWAs and then from UNRWAs towards end institutions. Some of our services, as we mentioned, are targeting end institutions, so we would like very much to be able to reach these end institutions with your help. So to conclude with some dissemination actions that we had this year, we had 28 persons from our work package presenting any of our work items at 23 events and giving 37 presentations. It was in different occasions, either the workshops that were organized by our work package that was mentioned in previous presentations, or at the conferences like TNC and the Internet to Global Summit and different SIGs. And also we are preparing for presenting our work in the forthcoming events such as DIE Conference, Internet to TechX, and the GEAN Symposium. I think that there was one question. Let me check in the chat. What material do you have to help us promote the services? For some services, we have some presentations. For example, for NMAS service, you can find a presentation on the NMAS website. We will share this with you. For persona, at the moment, we are creating a video with the help of Work Package 3, Carl Meyer. So we plan to have even more similar material. But we would be happy to prepare some material, and also for persona, there is a lot of material on the persona website, but we would be happy to work with you depending on the occasion, because we know that, for example, the same material might not be appropriate for different type of user groups and for different events. So if you are interested, please contact us, and we would be very happy to work with you to prepare the materials that you need. Anna, is this okay? Okay. So Rudolf asked regarding slide 3, don't you think the task 1 is now manpower underestimating regarding number of items? Well, it depended a lot on the people that applied to work on some work items. So during the project preparation phase, when we had a call for people to join our work package, then we asked for people to be able to provide at least 40% of their time to work on our tasks. However, particularly in task 1, this was not the case. So for some work items, we had applications on only 10 or 15%. So we were actually balancing between who applied, the amount of manpower with which they applied, and the overall available budget per topics. So unfortunately, this is the final result. But at the moment, apart from the DTN team, we did not experience two big problems that we were very much understaffed and that we rejected somebody who applied, but we could not provide the manpower within the project. So was there, so Rudolf, does this answer your question?
Yes, perfect, thank you.
Okay. So, Pavle, do you want to comment on what you wrote in?
Well, no, this was just a response to your message. So.
Okay, okay. So with this, we are coming to the final slide. Tim, would you like to give the conclusion?
Oh, or you can continue. I don't mind.
Okay, so much about our scenario. Okay, thank you. So just to conclude today's InfoShare, as you can see, all tasks are on track, and a lot of team members are really very active and really trying very hard to achieve all the objectives and to produce some tangible results. We had two deliverables that are published, and one is on final review, so we expect it to be published either today or tomorrow, but definitely before the end of this month. So with this, we will complete all of our year 1 deliverables. We had 5 milestones and we achieved them all. We have only one more in year 1, which is due end of this year, and we have already started to work on this. So we expect this to be done on time too. We have all our KPIs as defined in the technical annex achieved. We are pretty much confident that project-wise we are on the right track, but this is one more reason why we are happy to have this InfoShare today, to hear from you if there are some other areas where you would like to see us focused, or if we have missed something out of these things. And we have also defined our year 2 plan, and you could have heard from those future steps elements in our presentations what is the plan for the second year. And we are really always very happy to hear any inputs from you, either during this InfoShare or offline via direct contacts or mailing lists, because we really believe that everything that we are doing, that we want to do this so that Andrens would use it, and that it would be useful, and not just because it is written somewhere or because we would like to work on this. So thank you all very much. I would now stop sharing the presentation, but we are very much open for any of your other questions or comments.
Yeah, could I step in just for a second?
Please.
Hello, Jakob Tendel from DFN here. Sorry, I don't have a camera right now. Well, first, congratulations to a very well-run year one, apparently. Great to see. I have a question for Tim, going back to his initial presentation.
Sure.
About the DTNs, data transfer nodes. You mentioned that one of your findings was that development of new software was not required. First, it's good to hear that existing software seems to fill the requirements of most communities, but I have anecdotally been receiving questions from various communities about data transfer management software. So are you planning to have a deliverable that describes a DTN installation together with some recommended existing software for high performance data transfer?
So one of the things we're pulling together at the moment from the reviews we've done outside of the survey is potentially a wiki that could include some information. We have to be careful with that though, because once you publish something like that, you then need to maintain it. So we have to look at the effort we have. But we believe from what we've seen that there's enough good or best practices out there that can be applied, and most of the issue is around not necessarily within the NRENs who are good at applying traffic engineering, doing the overlay networks where required, but are generally within the campuses, within the last mile. So I think those are the areas that need to be addressed. And the biggest gap seems to be, in many senses, between the researchers and the computer science, computing service departments, rather than within the NRENs and SHAON. So I think that's where that comes from. And there's enough tools out there, whether you look at the Globus suite or others that WLCG are migrating towards, that are available. It's a matter of getting the information about those out. That seems to be the comeback from the survey. There's lots of examples of NRENs trying to engage with campuses, promoting science DMZ principles, helping deploy things like file sender for sort of small to medium sized transfers. So I think that's where we're saying there's no obvious piece of software to be developed by the project.
One of the ideas that I seem to remember from the white paper process on this activity was the idea of looking at something like a DTN as a service for NRENs to deploy and offer to their user institutions. Did that ever go any further?
Yeah, I mean, in the survey, we asked whether NRENs are deploying DTNs on their backbone or potentially as a service, and I think there were 2 or 3 that replied saying so. Of how many responses were there, Ivana? About 25, something like that?
Yes.
So that's a very small fraction. I think there are use cases for NRENs deploying DTNs in the backbone. One is to provide a reference point for their campuses and institutions to test disk-to-disk transfers against. Second use case might be to put one on the backbone to help with long-haul transfers where the high RTT will mean that a small amount of packet loss has a much more dramatic effect. To do that for institutions that don't yet have a DTN or Science DMZ as a sort of a staging post for transfers. So I think there are potentially use cases there. And it's an interesting question as to whether you could do DTN as a service. I think that's the kind of approach that AARNet have done, for example, in the way they present storage to their organizations. I think they're using file sender under the hood for that. It's an interesting question, but we haven't seen any demand for that. I think it's more the case the NRENs, and we're doing this in JISC. We're getting out to the campuses, to the universities, and promoting them to deploy the data transfer nodes and the Science DMZ principles in their sites, and we're getting a fair amount of traction with that.
Okay.
But I'm very happy to talk to you about that after, well, not directly after the call, but catch you by email
sometime.
And discuss it a bit
further. Sure. Because we've kind of been keeping an eye on this activity to see whether there will be sort of a standard solution from the NREN community that then would be interoperable, and then all NRENs could deploy that. It was that sort of idea of thinking about that for the future. Okay, well, thanks very much for your answers.
I'll ping you at some point after the call and we can chat further. Thanks.
Yeah, sure. Cheers.
Any other questions or comments? If not, that might mean that we can conclude the call. So thank you all very much for joining this InfoShare today. And we are looking forward to hear from you offline also. And wish you all a nice afternoon. And goodbye.
Thanks very much. Bye-bye.
Thank you. Bye.
Bye.
Thank you.
Thank you.
Thank you very much. Bye.
Hi to Cambridge, by the way.
Bye.
Hi, guys.
Bye.
Bye-bye.
Bye.
Bye.
Bye.